The next application of linear is to parallel and perpendicular lines. So parallel, I kind of think about parallel like I do in gymnastics, the parallel bars. And so the parallel bars look like this. And what we know about the parallel bars is that they never will meet. So parallel lines basically never touch each other. So if we look at that in the form of a graph, you can see here we've got two linear equations graphed. This graph here is y equals half x plus 5. And this graph here is y equals half x plus 2. So we can see here that this has a y-intercept 0, 2. And this has a y-intercept of 0, 5. What we can see here is that they have exactly the same gradient. And what we talked about is that gradient there, by definition, is as x increases by one value, we can see that it goes up by the gradient, which is a half. So this grows as x goes up by 1, the y values go up by a half. And this grows at exactly the same rate. Okay, as x increases by 1, the y values go up by a half. What that means is that they're both growing at the same rate, which means that these two lines will never meet. As this one goes across and up, this one will go across and up at the same rate. So the distance between the lines will always remain the same. They'll never actually touch each other. So we say that these lines are parallel, and we can tell whether two lines are parallel if we check the gradient, and the gradient is the same. All right, now the other thing that we're looking at today is whether lines are perpendicular to each other. So perpendicular basically means the lines are at right angles. So you can see here on the graph that both of these graphs intersect at this point here, but the intersection for perpendicular lines is a particular type of intersection, and that is that it has to be at right angles. Okay, now there's a good way to check this. So you can check whether two lines are perpendicular to each other by using this formula here, which is that you multiply the gradients of the two lines. Let's just try it out for this one here. So we've got 3 times negative 1/3. So I've got the gradient of this line, which is 3, and the gradient of this line, which is negative 1/3, and we can multiply that. And what we're going to find is that's negative 3 over 3 when I multiply it, which is negative 1. Now, if the two gradients, when multiplied together, equals negative 1, it means that the lines are perpendicular to each other, which we can see that, we know that. But that's a good way to test whether two lines are perpendicular. Now, the other way to use this concept here is, as the notes say, the gradient of one of the perpendicular lines will always be the negative reciprocal of the other gradient. Okay, now that sounds a little fancy, but all it means is to find the gradient of a line that runs perpendicular to another, simply take, well, I'm not going to say take, simply negate and flip. All right, so negate and flip. Okay, so this is what this sentence says, albeit it's a bit more mathematical, I would say. So what does it mean? Okay, so what I want to do is, if I'm given the line y equals 3x take 1, and what I want to do is find out the gradient of a line that runs perpendicular to this, okay, all I do is I note that the gradient here, m1 we're going to call that, gradient 1 is 3. So if I negate and flip this, what is going to happen is it's currently 3 over 1. So that means our gradient of our line that runs perpendicular is going to be that flipped, which is 1/3, and then negated. So we throw a negative sign out the front. And that technique will work with all gradients. So basically, let's try another one. Y equals negative 2x plus 1. So you can see here that the gradient of this, m1, is negative 2. So if I flip it, it's going to become a half, and then I negate it, so it's going to be negative a half with a negative out the front, means that that's going to be a half. Okay, and again note that we could check that this indeed means that they're perpendicular by doing negative 2 times a half is negative 2 over 2, which is negative 1. Okay, and when that result happens, when you multiply the two gradients and you get negative 1, it does mean that the lines are perpendicular to each other. Alright, so let's just try that out. So the first example, decide if the graph of each pair of rules will be parallel, perpendicular, or neither. So we can see here that these two lines have a different y-intercept, so negative 6 and 2, but note that they have exactly the same gradient. Okay, so these two lines are in fact parallel because they have the same gradient. Okay, all right, let's do the next one. So this one here, you can see that they don't have the same gradient. So this graph here has a gradient of negative 3, and this graph here has a gradient of 1/3. So what I'm going to check is, well, they're definitely not parallel. So I'm going to check whether they're perpendicular, and to do that, what I do is I multiply the gradients together, and if the answer is negative 1, it means they're perpendicular. If it's something other than negative 1, we're going to select this option here, which is neither. So let's find out. Negative 3 times 1/3 equals. Now, feel free to use your calculator on this one as well if you don't want to fumble around with the fractions. So I'll try this one on the calculator. So it's negative 3, I want to negate 3, and then multiply that by, so I'm going to go shift, is it control divide? Shift divide. Yeah, control divide, 1/3, and we hit enter, and we get negative 1 as our answer. Okay, so that by hand would be negative 3/3, which is negative 1. Okay, and we're going to say that they are perpendicular as m1 times m2 does equal negative 1. Okay, and if it was a number other than negative 1, we'd say that they are neither parallel nor perpendicular. Alright, so just note here that equations of parallel or perpendicular lines can be found by first finding the gradient, then substituting a point in to find c in y equals mx plus c. Now what on earth does that mean? Let's just try it out on this example. So we want to find the equation of the line that is parallel to this one and goes through this point here. Alright, so the technique I'll use is as follows. So I know that the line that runs parallel to this is going to have the equation y equals negative 2x plus c. Now how do I know that it's going to be negative 2x? Well, it's because it has to have the same gradient for it to be parallel. So I know that this will be the gradient of the line. What I don't know is the y-intercept. Okay, now what do the notes say? The notes say that you can substitute a point in to find c in y equals mx plus c. So I'm going to substitute this point into the equation, and what that will leave is c as the unknown. Now, how do I know what to sub in? Well, our coordinate is 1, 9, and that's the x value, and that's the y value. So let's pop the y value in, which is 9, pop the x value in, which is negative 2 times 1 plus c. That's 9 equals negative 2 plus c. Now, you could, if you wanted, solve this on the calculator for c, so you could use the solve feature, and I'll show you that in a sec. But hopefully you can see that if I had 9 equals negative 2 plus c, to find out what c is, in fact, what you do is the opposite of this takeaway 2. So you add 2 to this side and add 2 to this side, and that means c is equal to 11. So our equation that's parallel and goes through 1, 9 is going to be y equals negative 2x, and we're going to replace our c that we just wrote down here with what we just found out, which is 11. So that's our line. Now if we wanted to do it via a solve, what we're going to do on the calculator is go menu, algebra, and 1 for solve. We type 9 equals negative 2 plus c, and we want to solve that for c. And it says that c is 11. Alright, so part B, what we want to do is find the line that runs perpendicular to this line here and passes through this point here. Okay, so what do I know about lines that run perpendicular to each other? I know that if I multiply the gradients together, it equals -1, but I also know that the gradient of this first line here is 1/4. To get the gradient of the second line, all I do is I flip this, which will become 4/1, or 4, and negate it. So it's going to be -4. So I know that the gradient of the line that runs perpendicular to this equation here will have a gradient of -4. So I'm going to write that in. Y equals -4x, but I don't know what the y-intercept, so I'm going to write that as plus c. Okay, so now I need to work out what this plus c is, and I'm going to use exactly the same strategy that I just used, which is using this point here that they give you. We know that it passes through this point here, so what I'm going to do is 3 is the x value, y is the -2 is the y value, so let's pop those in. So where I see y, I'm going to replace it with -2, and where I see x in here, I'm going to replace it with 3. So that's -2 equals -12 plus c. Now to solve for c, what I'm going to do is either do it on the calculator, or I'm comfortable adding 12 to both sides. -2 plus 12 is 10. Okay, so our equation is going to be y equals gradient -4x plus c is plus 10. Let's just see what this will look like if I graph these. So I'm going to load up this graphing program called GeoGebra. Okay, so the first two lines I'm going to graph are the parallel lines. So we found out that this is the original one, y equals -2x takes 7. Okay, so there's the graph of that. Okay, and what I'm going to do is graph this one here, and what should happen is this line here should be parallel. So y equals -2x plus 11. So we can see clearly that they are parallel, but it also should go through the point 1, 9. So let's find out whether it does or not. So 1 would be here, and 9 is there. So it certainly does go through the point 1, 9. So that does meet the requirements, and we can see when we zoom out here that these two lines are definitely parallel. Okay, let's try the second one, which is the perpendicular one. Okay, so excuse me, what I'm going to do is graph the first line. Y equals 1/4 x take 1. So there it is there. Alright, and what should happen is when I graph the second one, it should run at right angles to this first line. So we know that the equation of the second one is y equals -4x plus 10. And we can see pretty clearly, I'm pretty sure that's at right angles too, so that looks good. And it also needs to go through the point 3, -2. So when x is equal to 3, y should equal -2, and it does go through that point there. So we can see here that that equation there fulfills the requirements of the question. Alrighty, so your time to try this out. Okay, so there's the exercise there, and good luck with it.